Okay, so I have something really cool that I wanted to be able to share. Kind of shared this same idea before, but it's this idea that plant medicines are far greater teachers than they are therapies, but this also applies to pharmaceutical drugs. And so I'll share a really cool story with you guys today about Labrador Tea and Metformin are far greater teachers than they are therapies. So when we're looking at the Labrador Tea, one of the things that we have to understand, first of all, is that plant medicine and pharmaceutical drugs are not that much different. Not saying they're the same, and I'm not saying one is better than the other. But it's very simple to understand. When you're looking at plant medicines, they operate by chemicals, and each medicine is going to have 100 to 250 different chemicals inside of it that all have a physiological action, or a way to accomplish a goal that is healing. And a pharmaceutical drug is a synthetic mimetic. All they do is they take a plant chemical out of 250, they take the most active one, and they map out the mechanism of action. How does this medicine accomplish that healing goal? And now let's create a synthetic mimetic that tries to copy that mechanism of action. And that is how pharmaceutical drugs are made. For the most part, over 85% of all of them anyways, and the remaining 15% are fungus or accidents. And so when you're looking at the from this perspective, is that plant medicines are plant toxins or poisons that are engaged with in a hormetic way, just like exercise is toxic and poisonous, right? But we don't obviously just do it to the point where we're completely destroyed and dead. We do it just enough so that we are able to adapt to that stress and become stronger. Stress is always an opportunity to become stronger, an opportunity for growth. And so we're taking advantage of all these plant chemicals as toxins to create this hormetic effect inside of our body so that we're always adapting to them and becoming stronger. It's not much different than pharmaceutical drugs in that they are both chemical poisons that we're having. We're just having them in a certain way. And then one of the other distinctions that separates plant medicine from pharmaceutical drugs is that plant medicines are not going to be just one chemical, 250 that are all working in a synergy to accomplish a goal. And they are doing the required mechanisms, accomplishing the required mechanisms, whereas pharmaceutical drugs, synthetic mimetic of one plant chemical. So, you decide which one is going to be responsible for more amounts of therapy, if you want to put it that way. But the point here is that both of them are and should be invalid as therapies. When we acknowledge plant medicines and even pharmaceutical drugs as teachers, that's when things really start to make sense. So when you're looking at Labrador tea, Shkigabuk we call it, but the Latin name is Rhododendron groenlandicum, which in all of the studies was Ledum groenlandicum. Since then, it has been reclassified to rhododendron. But if you want to fix your query a little bit, Ledum groenlandicum is going to come up with a lot more results if you want to actually look up the mechanisms of Labrador tea. So all it does, basically, it does two things. It stimulates or activates Ampk kinase in the liver, and it increases the expression of GLUT4 transporters on cells, allowing sugar to enter into skeletal muscle tissue. And so those are the only two things that it does. The AMPK, adenosine monophosphate activated protein kinase expression or activation in the liver, basically just tells the liver to stop producing sugar, to stop spewing it into the bloodstream. Which is usually what insulin does. So like every time you eat, you produce insulin, whether it's from proteins, fats, or carbohydrates. You're always going to have an insulin response after each meal. Obviously with carbohydrates, it's much higher because there's way more amounts of sugar that is occurring. And so what that insulin does is it tells your liver to stop producing sugar, to stop spewing it into the bloodstream. And when diabetes becomes detectable is when your liver becomes resistant to insulin, where it says, I'm not going to listen to insulin anymore. And it is whether while you're eating, your liver is constantly manufacturing and spewing out sugar into your bloodstream. And it's at that point in the development of diabetes where your pancreas can no longer make any amount of insulin to be able to control those blood sugar levels when your liver is manufacturing it and spewing it out while you're eating it. That's where it becomes unmanageable. So, the activation of AMPK in the liver, very, very appropriate mechanism for Labrador tea to take advantage of, to say, hey, stop producing sugar, stop spewing it out into your blood. Now your blood sugar levels are going to be much more controlled, but also increasing GLUT4 expression on the skeletal muscle tissue. allowing sugar to enter into your muscles, because when we're eating a rich carbohydrate diet, not exercising and eating a lot of vegetable seed oils, your muscles will become resistant to insulin. They're not going to allow the sugar to enter into the muscles. So then that sugar is sacrificed into endothelial cells, mesangial cells in your kidneys, your nerves, and your eyes, and hence diabetes related complications, right? And so when Labrador tea opens up your muscles, allows the sugar to go in, then it can be burned. Your blood glucose levels are controlled. So looking at metformin basically does the exact same thing. Metformin increases Ampk in the liver, and it increases GLUT4 expression on the surface of skeletal muscle cells. Those are metformin's two primary, exact same as Labrador tea, and exact same mechanisms have been proposed for each. Glyceraldehyde 3 monophosphate dehydrogenase, or phosphate dehydrogenase inhibition, complex 1 inhibition, and AMPK activation by AMP deaminase. Same mechanisms of each have been proposed for both the Labrador tea and the metformin. So they're all both doing the exact same thing, even chemically. But I think that complex 1 inhibition at the levels of metformin that people are ingesting is not an appropriate application of an explanation to its mechanisms. Anyways, they're both doing the exact same thing. But what is actually occurring? And I think the most important thing to understand is that what these medicines are capable of doing, exercise can do way better. And exercise is even a prerequisite to the mechanisms of both the medicines and the medications even working. Because if you're allowing sugar to enter into the muscles to bring your blood sugars down, that's great. But if your muscles aren't moving, then this entire mechanism is just absolutely inactive. It's not effective at all. Prerequisite to this therapy is actually moving, but it's telling you too, like because when you get moving, any diabetic who is taking Labrador tea and metformin and not moving, any diabetic who begins moving is going to have way more GLUT4 activation and expression on their skeletal muscle tissue than a diabetic who is taking metformin and Labrador tea but not moving. See what I mean? We're able to learn from these medicines what the actual mechanism is, it is able to accomplish something. We are able to accomplish something that just the medicine is not able to come anywhere near. Now, AMPK activation in the liver, this is something that we could do by carbohydrate restriction, and restriction to absolute zero, which is the human requirement for carbohydrates throughout our entire lives. Zero. Not supposed to have any. And so this is why when you take people who have diabetes who are getting A1Cs of 11 and 18 and 24, and in 3 months when we get their A1Cs again, it's 4.5 when they remove the carbohydrates. That's why this intervention is so powerful, is because we're listening to the medicine, we're listening to the medication and saying, well, the best way to stimulate AMPK in my liver is to remove carbohydrates completely. When you remove carbohydrates completely, you're doing something that both those drugs, both the medicine and the drug, are not able to come anywhere near capable of doing whatsoever. So listening to medicines as teachers does not just apply to plant medicines, but it applies to pharmaceutical drugs as well. I mean, you look at statin drugs. Statin drugs, their mechanism is not in their cholesterol lowering effects. It is very, very well known that that is a consequence, a side effect to statin drugs. The mechanism of statin drugs is to lower the toxic effects of glucose on endothelial cells, to protecting your endothelial cells from sugar, from hyperglycemia, and thus reducing the amount of inflammation that is occurring in this tissue. And then there is less glycation, less LDL particles sinking in behind the endothelial cell wall, where they become glycated and attacked by macrophages, turned into a foam cell, and become an atherosclerotic streak. So listening to our heart medicines as well, they all are protecting our endothelial cells from the damaging effects of sugar. Statin drugs protecting us from the damaging effects of sugar. So let's listen to both plant medicines and pharmaceutical drugs and say, well, what's the real therapy here? Let's look at them as teachers and say, what are you going to be really capable of when you listen to these listen to what they're saying? Eliminate the sugar. Just get rid of it completely. The human requirement for carbohydrates is and always has been absolutely zero. And so I wanted to project this responsibility on healthcare professionals, on people learning about nutrition, learning about plants, learning about medicines. Don't just learn about the medicine, learn the story that it has to share, because you're going to be able to accomplish a far greater healing in any case than what that medicine is able to do. And so I just wanted to share that simple, I guess, responsibility of ours to understand that medicines are greater teachers than therapies in almost every case. Aha, chumigach. Bum on pace.